All right, good morning. Good morning. It's the second to last lesson of the year, so I know you're all excited. Matter of fact, if you're a screen counter, like a lot of my in-person students are, you'll see it says 8 slides, and I'll say there is noticeably less than 8. We're going to be talking about angle measures and segment lengths inside of a circle and some a little bit outside of a circle, but we start off with a new vocab word called secant. As you're writing that, I'll tell you there's 3 ways that a line and a circle can interact with each other. One way is you could have a circle over here and a line that never touches it. That's one way they could interact. And then the other day we learned about when we have a circle and then a line just nicks the circle at one point and then goes on and never touches it again. We called that a tangent. Now today is probably the most common way that a line and a circle interact, and that is when a line hits a circle, goes inside of it for a little bit, and then pops out the other side. So when a line hits a circle at 2 points, we call that a secant. And so we're going to be talking a little bit about that today. So finish jotting that down, hit pause if you need to, and then we're going to move on to screen number 2. Exciting stuff. Okay. Now here's where things get interesting. We're going to have our first formula of the lesson right here. And again, you've got the measure of an angle formed by 2 lines that intersect inside the circle. So that's the key word on this one. On this slide, we're going to use this formula when the lines intersect inside the circle. We use this formula. So again, copy that down, and I will process it. And here's what the formula says right here. It says the measure of angle 1, that's this guy right here, is going to be half of the 2 arcs that it creates, arc X plus arc Y. It doesn't matter what order you add those arcs in. As you know, 7 plus 8 is literally the same thing as 8 plus 7. So the order doesn't matter when you're adding. I usually, if this is my angle I'm talking about right here, I usually refer to this arc as the front door arc, the one that's in front of it. And then this one over here is the back door arc, but that's not super important, just the one in front and the one in back. We don't care about this one up here or this one down here. And there's the magic formula. And that is when these lines intersect each other inside the circle. Now, on the next slide, they're going to intersect outside the circle, and that changes one molecule of our equation. And you'll see here in just a minute. All right. 2 down, noticeably less than 6 to go. Okay, here are the 3 ways that they can intersect outside the circle. You could have 2 of these new things we learned about called secants. They could meet outside. You could have 1 secant and 1 tangent intersecting outside, or you could have a double tangent intersecting outside. It doesn't matter any of those 3, you still use this formula, and at first glance you're thinking, Mr. Metcalfe, that looks like the exact same formula, but it's not. One thing has changed. Does anybody notice? Sure you do. We've changed from adding the 2 arcs together to subtracting them. Now I will tell you this, order does matter when you subtract, because 7 minus 8 is different than 8 minus 7. So there is a specific order. Now, I refer to the first arc, the one in the X in red, I refer to it as the far away arc. So far. Far from what, Mr. Metcalfe? Well, the angle. All right, we're trying to find angle 1. So the far away arc would be X, and then Y would be the close arc. All right? And I think that makes sense. It's the one that is close to the angle. So you do need to put the far arc first minus the close arc second. All right? And you'll notice in each one, the X is far away, the Y is close, X is far away, Y is close, X is far away, Y is close. Now, one thing that will help you with that is the far away arc will always be bigger than the close arc. So when you subtract, you always get a positive number. If you subtract and get a negative number, you know you have your arcs in the wrong order. All right, so hit pause if necessary, and we're going to do a few sample problems. You ready? 3 down already. We're cooking with grease today. Okay, so here we go. We got 4 problems. I noticed the very first one, they intersect on the inside, so you'll use the inside formula for him. But these 3, they all intersect on the outside, so you're going to use the outside formula. So give you a chance to pause and copy those down. Take a shot at answering them. I haven't processed one yet, so you might get it wrong. That's perfectly okay. And I'm going to pretend like you've done that. You've tried at least this one and this one. You've tried at least one inside and one outside one. All right? And now let's see if you got them right. Okay. As mentioned, this one is an inside where they intersect. So you use this formula right here. And I'm going to write it. Let's see. Hopefully, I'm going to write that formula right here. The angle is equal to half the arcs added together. And again, in the ones where they meet on the inside, it doesn't really matter. Close and far, that stuff doesn't matter because we're adding them, so the order doesn't matter. So now, one thing that's going to happen is sometimes they will give you both the arcs as for the angle. That's an easy problem. But sometimes it'll be one of the arcs that's missing, and then you will have to manipulate this formula to solve for the missing piece. So please don't think that you always put the 2 numbers here and here. You put the 2 arcs here and here. All right? Some problems they might tell you the angle, so you'd have to put a number there if they tell you the angle. But this one they don't. The angle is the missing piece. So the angle, they're calling it E. So I'm going to say E equals 1/2. And then my 2 arcs, the front door arc is 46, plus the back door arc is 90, and I've got pretty easy problem I can do. So again, 46 and 90, that's going to be 136, and they want me to take half of that, and half of 136 will be 68. So this angle is 68 degrees. All right, hopefully you got that. If you didn't, now you know how to do it, and we'll move on to the second one. All right, and here's the first problem where you're going to have to really use your Algebra 1 skills to manipulate that formula, because they actually tell you the angle in this one. It's 20. So one of the arcs is missing in this problem, and they're intersecting outside. So you have to use the outside formula. And that one is very similar to the inside, except for one change. So the angle is half the, what I call the far away arc, minus, now remember this one is the one where it's a minus subtraction problem, minus the close arc. And when I say far and close, of course I'm meaning far or close to the actual angle. So in this one, the angle is 20, so 20 equals half is always a half. The far away arc, well, if I'm standing here at 20, M is the close arc, it's 95, that's the far away. So 95 minus the close arc, which is M, that's the missing piece. All right, so now this one is not just a straightforward, subtract them and cut them in half. This one you're actually going to have to manipulate this formula. And there's a couple ways to do that. Your Algebra 1 teacher probably had you distribute that half into the parentheses, and that's perfectly fine. If you feel comfortable with that, do that. I don't like that style on this one because it's going to get messy. Cutting 95 in half, that's going to be a decimal right off the bat. And then you're going to have a half of a negative M. So to me, if there's a shortcut, I'm going to take it. And there is. Whenever you're multiplying something by a half, you could get rid of that half simply by multiplying by 2, right? If you multiply a half by 2, 2 halves, of course, makes a whole, or 1. And you notice when when you multiply something by 1, it doesn't change it. So when I multiply this half by a 2, it literally cancels out the fraction, and then I'm just left with 95 minus m. And to me, that's way easier to deal with than cutting the 95 in half and then having a half of an m. Now, the other side of that, literally, is if I multiply this side by 2, I've got to be equal, I've got to be fair to the 20 and multiply it by 2. You can't just multiply one side of an equation by 2 and let the other one do nothing to it. You got to do the same thing. So I multiply it by 2. So the 20 is not 20 anymore. It's now 40. All right. So now we've got a pre-algebra problem. That's all that's left is getting rid of that 95. And maybe we got to get rid of that negative off the m. But let's get rid of the 95 first by subtracting 95 from both sides. And for a moment, you will get temporarily scared because we have a negative 55 over here. But then you'll remember that's okay because we have a negative m as well. So if negative 5 equals negative m, you know what positive m is going to be. That's right, positive 55. So hopefully everybody got that one. Okay, 2 down, 2 to go. I'm going to erase some of this scrap work, so if you haven't copied it at this point, make sure you do. And you hit pause, and bye-bye scrap work. Okay. So, we have another problem. Ooh, I like this problem we're about to do because it's even got a shortcut. And so far, out of the 4 classes I've taught this to today and yesterday, 3 of the 4 have figured out the shortcut on this one. We're going to do it normally at first, and then I'll tell you the shortcut if you haven't figured it out already. But in this problem, again, they meet on the outside, so you're going to use that outside formula. Let's jot that down. The outside formula is angle equals half the faraway arc minus the close arc. And again, you don't just put the numbers in the parentheses, you put the numbers where they actually belong, what they actually represent. And in this one, again, they are telling me the angle. They're telling me the angle is 70, so I'm going to put the 70 over here. I've had a lot of people put 110 and 70 here and here, which the 110, that makes sense because it's one of the arcs, but the 70 does not. It's the angle, so it goes out front. So that's going to equal half, because half is just a half. If I'm standing here at the angle 70, the far away arc is B. So it's going to be, there's my variable, B minus the close arc is 110. And again, we have that same situation. We're about to distribute a 1/2. If you like doing that, please continue doing that as long as you do it correctly. This one isn't too bad because the number is even, so it's going to come out smooth. But I'm still going to do the little Metcalfe trick of making that half go away by multiplying by 2 and then multiplying this side by 2 to be fair. Over here, the 2 and the half cancel out. I'm left with B minus 110 equals, not 70 anymore, but 140. And so all I have to do now is get rid of that minus 110. So I add 110 to both sides, and I get B equals 250. Now there's a shortcut on this one. I don't know if anybody noticed it while you were doing that. They're like, you might have thought, well, Mr. Metcalfe, I see an easier way to do that. All right. If you do, please copy the scrapbook first because I'm about to erase it. And I'll show you the shortcut, if I can do this without erasing any of the important stuff here. Okay. So somebody in 3 of the 4 classes so far noticed, hey, if this arc is 110 and B is the rest of the circle, couldn't I just take 360 minus off the 110? Absolutely. Guess what you get? 360 minus 110, you also get 250. So if you have a double tangent problem, this will happen, but it's only going to happen on double tangents, so be careful. 250. All right, last one. So again, they meet on the outside, so hopefully you use the outside formula, which is angle equals half far arc minus close arc. All right, So now we just put all the pieces in the puzzle in the correct spots. Not where we want them to go, but where they do go. All right? So in this one, the angle is t. So the angle is the variable. Usually students like these problems the best. When the variable's over here on the end, then you don't have to do as much algebra. All right? Half is just a half. And again, if I'm here at the angle t, the far away arc is 110 again. Actually, he was the close arc last time. Minus the close arc, which is 30. So this is a more simple problem because you don't have to do as much algebra. You just have to subtract 110 minus 30, which would be 80. And then you don't forget about the half. And I think everybody knows half of 80 is 40. So T would be 40 degrees. And hope you got those. If you didn't, you're going to have more practice on the activity sheet coming up here in a few more screens. And if you have any questions, don't hesitate to send me an email or go to Mr. Crabtree's Google Meet, which I think this week is on Friday at 2:15 to 3 o'clock. Pretty sure. Always check Google Classroom for the exact time. And we'll move on. Man, we've done 4 screens, and Mr. Metcalfe said there was going to be noticeably less than 8, so I wonder what's going to happen next. Boom! Additional examples if necessary. I don't think it's necessary. This is pretty easy stuff, right? So we'll move on to screen 6, and this looks really confusing. So now I'm going to switch gears on you. Instead of talking about the angles and the arcs, we're going to actually talk about the lengths of these segments, these different pieces that are broken by the circle, or broken by each other too. So now forget about arcs and angles. We're talking about the actual lengths of these segments, and this looks really complicated. This is how the book is kind of required to say it. They have to use math terms and math formula style. Math teachers, we can explain it in a language that's much easier, and I promise you I'm going to do that. There's basically 2 styles. This one where they meet on the inside again, so we're still talking about meeting on the inside, meeting on the outside. He's got his certain formula, which I'm going to make easier than that. And then these two, they're 2 separate instances of the same thing, but these 2 are meeting on the outside and meeting on the outside. And they have a different formula as well, but it's much easier than this gobbledygook down here. So take a few seconds and write it, copy it down, hit pause if you need to, and here we go. So the Mr. Metcalfe way to look at this is, instead of thinking of it as A times B equals C times D, which it does, that's what it says right here, think of it this way. Piece, which I'm going to use the letters PC, this A piece times the B piece will equal the C piece times the D piece. Now, you telling me, Mr. Metcalfe, that's all true every time you cross 2 lines in a circle? Absolutely. It's a theorem, so it's been proven to be true. Now, this is the example I like to show students that sometimes blows their mind. Say I have a circle, and I make one of the chords really long, like all the way across, and then I make the other chord really short. Does this still work on this? Absolutely. So you're telling me, Mr. Metcalfe, even though that chord is really long and this chord is really short, that if I multiply A times this little bitty piece right here, this little piece, it's so small I can't even write a B in it. You're telling me that times that will equal C times D? Yes, it will. As in, hard to believe as that is, that multiplied by that will equal that times that. Even though that one is way longer in total length than he is, when you multiply their intersecting pieces, they are the same. So piece times piece equals piece times piece. Now, when they meet on the outside, you're going to have to look at it a little differently, all right? There's still pieces times another piece, but it's a little different. So on the first one, you see they say W times W plus X. A better way, easier way to think of it is W is the outside piece, right? He's the piece outside of the circle. So I'm going to call W the out piece, outside piece. And you're going to multiply that by this W plus X, which W plus X is the whole secant, right? It's the whole thing. So I'm going to call that whole, as in W-H-O-L-E, the whole secant. All right? And then, so to be fair, it should be the outside piece times the whole again. Well, if you look at the red secant, the Y is the outside piece. And it is getting multiplied by the whole thing, which is Y plus Z, the whole secant. And his formula will be the same. But you're saying, Mr. Metcalfe, he's got a T squared. None of these guys have any T squareds or anything like that. What's weird about him is because T is the outside piece, right? He's the outside piece, and at the same time, he's the whole secant. So if T's the outside piece and T is the whole thing, that's how you get that T squared. So it's still following outside piece times whole equals outside piece times whole, because Y, of course, is the outside piece of him, and Y plus Z is the whole thing. Now, that seems complicated right now, but when we do these problems on this next slide, you'll be like, oh, okay, I see what he means by the outside piece times the whole. Okay, and that takes us to the last screen. But Mr. Metcalfe, it says that there's 8. I remembered moments ago that screen 8 is just some of your homework problems written out. But again, if you don't want to write this red stuff right here, that's where it says piece times piece equals piece times piece. And this gold stuff is where they meet on the outside. Outside piece times whole equals outside piece times whole. You just wrote that, so you don't need to write it again. Have it there because I'm going to refer to it. So if you look at these 3 problems, or 4 problems, I should say, 3 of them, the segments meet outside. These 3, they meet outside. So you're going to use the outside formula for those. And in this last one, they meet on the inside. Now be careful, a lot of kids in class are having trouble seeing that is not 65, it's 6.5. So be careful as you're doing that problem. So take a second and attempt these, at least attempt number 1, and then we'll process it together here in just a moment. All right, and we're back. So hopefully on this first one you said, he meets on the outside, so I'm going to use that whole weird thing Mr. Metcalfe said called outside piece times whole equals outside piece times whole. And now with numbers instead of all letters, I think this will make more sense. So let's look at the secant on the top, the 6 and the 8. Well, I think everybody kind of understands that the outside piece is 6, right? That makes sense that that's the piece on the outside. So I'm going to put a big, juicy red 6 for the outside piece. That whole secant now is 6 plus 8, so that would be 14. And I got that by doing the 6 plus 8 for the whole secant. All right? Now I'm moving on to the bottom secant. It's still the same format, outside piece times whole. Well, the outside piece of him is 7. And then the whole thing, here comes the algebra. 7 plus y would be that whole secant. 7 plus y. Mr. Metcalfe, it looks like we're going to do the distributive property. Absolutely. You are going to multiply that 7 times 7 and then 7 times y. But first, 6 times 14, you'll never believe what that comes out to be. 84, 84, 80, 80, 88, 84. That's right. And then 7 times 7 you learned in 3rd grade is 49. And then 7 times y you learned in pre-algebra is 7y. Now, we got to find out what y is, so let's get rid of that 49. So let's subtract it from both sides. And you get, that's going to be 35 equals 7y. Ooh, this one's going to work out nice and smooth because now we're going to divide both sides by 7. And that cancels out, so y equals 35 divided by 7, which is 5. All right, they're not all going to work out nice and smooth like that. We're going to get some decimals, but that one did work out pretty smooth. Okay, here comes the weird one. All right, they're meeting on the outside, obviously. So we're going to still use that outside piece times whole equals outside piece times whole. But look at the top secant. Matter of fact, it's not even a secant, it's a tangent. It's just touching the circle once. So the outside piece is z. That is a z, by the way. You notice by the little slash in the middle of it. That's a z, as in Zulu, not a 2. So the outside piece is z. Then, here's the weird part that throws students off sometimes. The whole thing is also z. So the outside piece is the whole thing. So we get z times z, and that's where we're going to get a z squared. Now, let's look at the bottom one, which is a secant. All right, the outside piece is 8. The whole thing is 8 plus 16, which of course is 24. All right, so now z times z is not 2z. That's what z plus z is. Z times z is that weird thing called z squared. And 8 times 24, don't tell me. That's going to be 160 plus 32. That's going to be 192. You may want to check behind me because I'm freestyling. Even though I'm recording this, I sometimes like to freestyle. It makes the math more fun for me. So now all we got to do is get rid of that square. Well, we've learned in here, if you've been paying any attention, that to get rid of a square, you root and you root. Because roots cancel squares. So z is going to be whatever the square root of 192 is. Grab my handy dandy basic 4-function calculator, which doesn't work very well when the lights are dim, but we'll probably get enough light. 192, hit the square root button. It's going to spit out a 13.856, blah, blah, blah. So Mr. Metcalfe always likes to chop stuff off at the 10th spot. So we look at that first number that's getting chopped off. It is a 5, which is just enough to round that up to 13.9. Hopefully that's what you got when you attempted it. If you don't, you probably see now how easy it is. And I would assume everybody would get this problem right. All my MSO students who are doing this, hopefully you'll get it right. While I erase some scrap work area, hopefully you're doing this problem. It's meeting on the outside, so we're going to use that whole outside piece times whole equals outside piece times whole. And I've got it written right here, so I'm going to just use this. Outside piece times whole equals outside piece times whole. In this problem, the top secant, his outside piece is 14. The whole thing is 14 plus 20, which is 34. Now we move to the bottom secant. His outside piece is 16 times his whole thing is 16 plus x. And there's the algebra 1 right there, 16 plus x. Is that the distributive property again, Mr. Metcalfe? Absolutely. Now, first things first, 14 times 34. Wow, that's going to be, let's see, it's going to be 340 plus 4 times 34, 68, 136. So that's going to be a grand total of 476. Again, check behind me because I'm freestyling and doing scrap work in my head. 476. 16 times 16, I do know that. That's 256. And then 16 times x, everybody knows that. That's 16x. Oops. There we go. So now we've gone from geometry to algebra 1. Okay, to solve for x, we got to get rid of this 256, so we subtract 256 from both sides. That cancels out. You've got 16x equals 476 minus 256. That's going to be 220. And all you have to do now is divide off the 16. Divide off the 16. They cancel out. You get x equals 220 divided by 16. I'm going to use my handy dandy basic calculator. Divided by 16. It's going to spit out a decimal. Oh, not a very long decimal. 13.75. Well, if you round that to the nearest tenth, you would chop it right there. That 5 is just big enough to make that 7 round up to a 13.8. Awesome. I hope you got that at home. Last problem, I do believe. But I am switching gears on you because all three of these have met on the outside And look what these two guys do. They're meeting on the inside. So we're finally going to get to use that little easy piece times piece equals piece times piece. All right? That's the formula for inside. And clear me some workspace. So when they meet on the inside, it is just piece times piece equals piece times piece. All right? So let's look at the long piece. 6.5 times m. So that's his two pieces, 6.5 times m. And then the guy who's more vertical, his pieces are 3 times 7. Really? Is it that easy, Mr. Metcalfe? You set it up like that? Yes, it is. Now, 6.5 times m, you got it, 6.5 m. And then 3 times 7, 21. All you have to do now is get rid of that 6.5 m. So we're going to divide it from both sides. Divide by 6.5, divide by 6.5. They cancel out over here, leaving me with m equal to, take out my calculator, 21 divided by 6.5, and you get, you get kind of a long decimal, 3.230 blah blah blah. I chop it at the 10th spot. That 3 is not big enough to round it up, so it is just 3.2. And there you go. So that's figuring out at the beginning of the lesson angles and arcs when you're dealing with secants and tangents, and then the second half of the lesson finding segments when you're dealing with secants and tangents. What about that last screen, Mr. Metcalfe? As promised, these are just some homework problems. I did alter these problems on your worksheet. I'm pretty sure the version you're seeing in Google Classroom does have the alterations, and that makes these problems a little easier. You could do them without knowing those numbers in red, but it gets more Algebra 1-y, and I don't need you all to get more Algebra 1-y. I want you all to do more geometry. So yes, these 4 problems have been altered. You may want to check in case they didn't upload very well. All right, we're done. Just for your own knowledge, we're coming down the home stretch of the year. This is being recorded. If you're watching it in 2021, this is being recorded on Tuesday, the second to last week of school. You online students, you're going to be taking the test on Monday, or that's when it will open up, because you all have to start turning in those Chromebooks next week. So please take it Monday. If you're still missing a test, which a lot of you are, please take those before you turn in your Chromebook, because it'll be really difficult to take it once you've turned that in. All right, good luck. This will get posted soon.